Hello everyone, so welcome back to this channel. So in this video, I want to show you how to attempt trace table questions for your IGCSE exam. So just a recap here, trace table is a tool for us to record the value of each variable as the program is running. So by drawing out the trace table, oftentimes we can find out what is the purpose of an algorithm. In this video alone, we are going to attempt two different types of questions. First types of question involving you looking at a flowchart and then of an algorithm and then creates the trace table for that flowchart. And the other type of question requires us to write down the values of each variable in the trace table after looking at the pseudocode of the program. So just a side note here, these past year questions are taken from the year 2021 to 2022. So let's move straight into it. So this is one question. Let's read the instruction. The algorithm shows by this flowchart allows the input of an examination mark for a class of students. So I'm a teacher, so this program allows me to enter all the different marks of the student. And if I want to end the program, I will put in -1. And if a value of the mark is 80 or over, then a distinction grade is awarded. And the number of distinction for the whole class is calculated if over 50% of the class has 50 and 80 grades. So this class will be awarded a high commendable certificate. So this is the algorithm that does the job here. And our task here is to fill up the value of each of these variable as the program goes. So to make it easy to visualize, I have put the question and also the table side to side. And let's solve this question real quick. So we will start in this terminator symbol, start. And you can see that here we have an initialization code. Initialization, where counter variable and distinction variable are assigned to the value 0. So what you need to do here is just very simply write down the value of counter and distinction into a trace table. All right. And the next thing you need to take note of when you're solving trace table is this range of value here, which is the value for all the input values. And let's move on to the second part of our algorithm. The answer is the input mark. All right. And the input mark value should be the first value here, the input data provided. So I will put in 88 under the mark variable. So the next one is we have a decision variable, a diamond in the flowchart. Is mark equal to -1? So if you look into what is inside the mark variable, it's 88. Therefore, it is not equal to -1. I'm going to execute my program, this part of the program here. So counter will be incremented by 1. All right. So now my counter will be, instead of 0, I'll write a 1 here. And move down, is mark greater than or equal to 80? Which is correct because my mark is 88, right? So I'm going to do yes. My distinction variable also will be incremented by 1. So I'm going to have my distinction as 1 also. And once I update the distinction variable, I'm going to follow the arrow back to the beginning of the program. All right. So let's quickly go to the second input. Second input should be 74. All right. I'm going to write down 74 on my mark column here. And is mark equal to -1? It is not. So I'm going to output, I'm going to increment counter by 1. So I'm going to have 2. And because they are not greater than or equal to 80, I mean 74, I'm going to follow the no path instead. So in the exam, one tip is that try to use a pencil to follow the arrow so that you don't go to the wrong part of the program. Okay, so you can see I don't update my distinction variable in this place. So next, the third input mark, I should input 60. 60 is not equal to -1. So I'm going to increment counter by 1, 3, and because they are not greater than 80, I'm going to follow the no part. I'm going to repeat the process except 90. So 90 going to go here, and then counter incremented by 1. And because 90 is a good mark, greater than 80, so I'm going to go to the yes path, update distinction. So 2, and fifth input should be 84. Again, 84, we are going to increment our counter and also increment the number of distinction. Next input, 87. Again, our counter, distinction incremented. 95, our counter, our distinction. And 72, all right, it's not the end of the program. We still increment the counter, but not the distinction variable. And followed by 84, increment the counter, increment the distinction. 66, only increment the counter. So now, I am already here, because it's 66, so I'm going to follow the no path. Here we have our last input, which is the value -1. So input mark, so now mark will have the value of -1. So I'm going to put -1 here. And is mark equal to -1 now? Yes, finally. So I'm going to go to this path, and this is what we need to do today, award variable. Award equal to distinction divided by counter, which is the value of 6 divided by 10. 6 divided by 10, we got 0.6. So we just write down 0.6 on the award column. So is the award column greater than 0.5? So the answer is true, yes. So we're going to follow this path, and we need to output highly commendable. So on our high output column here, we need to write down the highly commended sentence. And after we output, we're going to go to the end program. So here we have it, the end result of our trace table. So to be honest, this is the easiest question in your paper 2 exam. One thing, even though they are very easy, you do need to be extremely careful, because how the marking scheme mark it is that they will mark it based on the number of columns you got it right. All right. And if you don't get the first or second row right, the following rows, your answers in the following rows will likely be wrong. All right, so that's the first question, easy peasy. So let's move on to the second question. Again, we have another algorithm, and the algorithm will terminate if -1 is entered at the list input. All right, so again, we need to fill up this table. It's worth 5 marks. Let's fill this up. So again, we always put the initialization values in our first row. So this is the initialization. So let's write down the value 0. Oops, let's change it. Okay, there's some problem here. All right, so let's put the value 0 into my list 1 and list 2 variable. And again, we can highlight our input data. Input list. So I know that the first input data I should use is 2. So I'm going to put 2 in my value, in my list variable. So now what we can do is just follow the program. Is list equal to -1? So 2 is not equal to -1. So I'm going to follow the no path here. I'm going to input a value, which is the second input value, 77. And let's go again. Is list equal to 1? No. Therefore, I'm going to go to this. Is list equal to 2? Yes. So I'm going to write list 2. I'm going to update list 2 value with the current list 2, which is 0, plus whatever that is inside the value variable here, which is 77. So my list 2 here will have value of 77. So I'm going to update my list 2 value to be 77. And once the update is done, I'm going to go back to the beginning of the algorithm. All right, so again, input list. So my next input is 2. And then is not equal to -1, all right? And then input value, the next value is 16. I'm gonna write 16 in my value column, and then move on. Is list equal to 1? It's not. List is equal to 2. List equal to 2. Yep, I'm gonna update my list too. So current list 2 is 77 plus whatever that is inside the value, which is 16. So 77 plus 16, I got 93. So my updated list 2 value will be 93. And then we redo the algorithm again. So this time we have a different list value here, which is 1. So I'm gonna write 1 into my list. And input value, my value here is 35. And is my list equal to 1? Yes, we have it. So I'm going to update the list 1 value. So my list 1 will have the value of 35. All right. And then I'm going to go back to the initial algorithm. Now I have 2 again. So my list will have the value 2. And then is list equal to -1? No. Input a value, which is -7. So my value is equal to -7. And since my list is equal to 2, I'm going to go to this path, update my list2 variable. So I'm going to do list2 93 plus -7, which is essentially a subtraction way here. So my new updated list2 value is 86. I'm going to go back to the beginning of the algorithm, do it all over again. So I have 5 here. Oh, my list value is equal to 5. So I'm going to write down value 5 here. Okay. And then um, I'm gonna do the input value is 18. All right, 18. So is list equal to 1? Nope. Is it 2? Also no. So I'm gonna go here and we have to output an input error message. So I'm gonna do input error message in our output column here. Okay. So again, go back to the initialization algorithm, and then 1 is my list value, 11 is my value, and then because it's list 1's value, I'm gonna update the value inside list 1. So I'm gonna plus 35 with 11. So I got new 46 in my list 1 variable. So again, repeat the algorithm. Be very careful here. Again, list is 1, value is 12, update the list 1 variable, 58, and then 2 is our new list value as I go back. So list will be 2, 20 is my value, and update my list 2 variable here. So I'm gonna have 106 in my list 2 variable. So once I'm here, look at the next input here, which is the terminator value, which is -1. So is list equal to -1? Yes. So which means we are now terminating the program. I'm following the yes path here, go back. And here we have something that we need to do. We need to output list1 is equal to list1, the value inside the list1 variable. So I'm going to output list1 is equal to, my list1 variable is equal to 20. So I'm going to do 20 here. So let me rewrite it in a better way. And the next thing we need to do is to output the list2 value. And I'm going to do list2 is equal to whatever 100. Oh, I made a mistake here. List1 shouldn't be 20, should be 58. My bad. And list2 should be 106. And then is list1 equal to list2? In our case here, list2 is bigger, so which is no. So I need to output another message that says list2 is bigger. It's bigger. And then the program will move on to the end symbol, which is the end of the algorithm. So that's pretty much it for this question. Again, if you get everything here correct, then you'll get full mark. All right, so let's move on to the third question, which is the last question on trace table for flowchart. All right, so again, this question is about inputting of examination mark, and instead of -1, the number 999 will end the process. And if the mark is 40 or over, then the pass grade is awarded. Number of pass grade is calculated. If this is under 50%, the class is offered extra help. All right, so let's do it very, very quickly. This question is very similar to what we did in the previous question, so I do encourage you to pause the video and try to solve it yourself. Because if you can solve this question, I'm pretty sure you're ready for IGCSE exam. So again, the initialization, I'm gonna do it very, very quickly. 0, 0, 0, 0, and our input mark is 88, first value 88. And then is mark equal to 999? Obviously not. So I'm gonna increment counter by 1. Oops, I put it into the wrong value. So 88 here should be the mark variable. I'm gonna increment the counter variable, and then because mark is indeed greater than 40, I'm gonna increment my pass variable by 1. All right, so let's move on to the second input, 24. Okay, so it's not 999 and counter incremented by 1. Since it doesn't pass, so I'm going to go to the mode path instead to do our third input. Going to be 60, and then counter increment by 1, pass also incremented by 1. 30, counter incremented by 1, but it doesn't pass. 44, counter and pass more than 40, so 44 is pass. And then 17, 6, not pass. 25, only increment the counter. 22, again, no one pass. 54, 9, and pass. We have another pass here. 6, 10, again, doesn't pass. So now we have the value 999 here, finally, in our mark variable. So let's write it down, 999. And here we are almost ending our program. Yes. So here they said help is equal to pass divided by counter. So let's look at what if my pass here divided by my counter should be 0.4. So that's my help variable. So is help less than 0.5? The answer is correct. Yes. So I'm going to output an extra help message in our output column. And then no, the program will end. So that's pretty much it. A very, very easy question. So that's the end of the trace table for flowchart question. And we'll now proceed to the pseudocode to trace table question, which is almost the same. It's just that you might need some prerequisite knowledge on pseudocode to better understand this question. Okay, so let's read this question up. The pseudocode represents an algorithm, and the predefined function diff here gives us the result of integer division. So when you put 9 diff 4, you'll have 2, which is basically the round down of the division here, because if you divide 9 by 4, you should get 2.25, but this function only gives the integer value of that division. Okay, so that's what diff function does. And the mod function will give the remainder of the integer division. So instead, 9 mod 4 will give 1, because if you divide 9 divided by 4, you should get 2, and 1 will be the division. And this is exactly what this function is doing here. All right, so let's look at this pseudocode and see whether we can answer it or not. Okay, so again, very much like the trace table question we did, you can see that they also do initialization. So, and let's write down the 2, 0 into our column here. So our first and last variable, I'm going to write 0, 0. And don't forget our input data. So my first input data is 8. So I'm going to write 8 into my limit column. And we'll now start the algorithm. My bad, it should be here. So there's a for loop here. for counter equal to 1 to a limit, again, you can see that this is a for loop and their counter variable is initialized to the value of 1. So I'm going to write down 1 here into my counter column. And then I'll do input value. So my second input should be 66. So I'm going to do 66 into my value variable. And then, so now my value is equal to 66. If 66 greater than or equal to 100, then I'm going to do this chunk of code. But because it's 66, I didn't parse this scenario condition. I'm going to proceed straight to the end if statement. And then next counter here, what it does, if you remember, is that it increments the counter value by 1. So now my counter value should have the value of 2. Oops, 2. And let's go to the next one. So my counter value is now 2. Input another value, which is 606. Now, 606 is greater than or equal to 100. Therefore, I'm going to do another check here. Is 606 less than 1000? The answer is correct. So I'm going to put first, assign the value first to value diff 100, which is 606 diff 100. Remember, 100 is the integer division. So if you divide 606 by 100, you should get only 6 with the remainder of 6. So my first should be the value of this. So I'm going to write 6 here. And my last is value mod 10. Remember, mod gives us the division. So it should also be 6. All right. And then if first is equal to last, the next chunk of code, which is correct, then I will output the whatever that is inside the value variable. So I'm going to output what is in our value variable, 606. I'm going to do an NIF. So let's go back. Now we have next counter again. So my counter will be incremented by 1. I'm going to accept another input, which is 6,226. Let's write down. Is it greater than 100? Correct. But is it less than 1,000? Not really. It's 6,000. So I'm going to go to the NIFs instead. So again, I'm not going to do anything with it. Let's move on to 4. Number 4. So input value. So my next value is 8,448. And I'm not going to do anything because it's not less than 1,000. I'm going to straight go to my next counter. So I'm going to do 5. And I have another value, 642. So 642 match our scenario here. It's greater than 100, but less than 1,000. So I'm going to do this again. First, 642 diff 100. Again, I'm going to do, let me erase this. 642 divided by 100. I should get 6 with the remainder of 42, correct? So I'm going to have 6. And then another thing is I need to do 642 divided by 10 and see what's the remainder. I will have 42, 4, 40, and my remainder will be equal to 2. So my last here should be assigned to 2. And because if first equal to last, this is not our case. Therefore, I'm not going to do anything here. I'm just going to increment my counter again to 6. And after 642, I should accept the value 747. All right. 747 is greater than 100, but less than 1,000. Therefore, we are going to do this chunk of code. 747 divide by 100. Since we only care about integer division, we have 7 as our value in the first variable. And then value mode 10. So 747. If you divide it by 10, you're going to get 70, 47, 4, 40, a remainder of 7. So let's write the value 7 into our last variable. And here we have another first equal to last scenario. So I'm going to output whatever that is inside my value variable. I'll put it here, 747. So hopefully now you can see what the purpose of the algorithm is. It's a follow-up question. And the next one, 77. So let me increment my counter. So 77 is my next input value, and it's not greater than 100. So I'm just gonna go straight to next counter instead. Do 8, which should be the last value for in our loop because our limit is 8. Another input value, 121. 121 is greater than 100 but less than 1000. So I'm gonna do first. So 121 divided by 100. Oops. Should, when we do 1 to 1 diff, right, 1 to 1 diff 100 should be 1. So my first is 1. And when you divide 121 by 10, you should get 1 as the remainder. So my last here should also be 1. So I have another scenario, first equal to last, 1 to 1. So I'm going to output the value. And after that, next counter here. So my counter will have value 9. But because it reaches the limit of this for loop, therefore that's the end of the program. All right, so that's the next question is an interesting one. They asked us to describe the purpose of this algorithm, and pause the video for a second to see whether you can find it out. And if you are aware enough, you should see that the program only output the numbers when the first value and the third values digit are the same. So what this program does is that the first point, it outputs 3-digit number, not just all the 3-digit numbers. In fact, 642 they don't output it, but 3-digit number that have the first and third digit, that have the same first and third digit number. First and third digit. So that's essentially the purpose of this algorithm. Not a very exciting one, but quite an interesting one.